practice problem where they give us these conditions. If the remainder is 2 when x is divided by 5, then x is divisible by 7. And they want to know if either of these conditions support that claim. Now, just an example here. They say, what if x is a prime number? Well, let's try a prime number. Let's say maybe like 37. So you notice right here that 37 is equal to what? 5 times 7 plus 2. So you see it's in this form. 37 is a prime number, and it's in this form. However, 37 is not divisible by 10. 37 would be your x, and it's not divisible, excuse me, not divisible by 7. So 37, in this case, not divisible by 7. Not divisible by 7. I'll abbreviate that by 7. There we go, by 7. Okay, so we have to cross this out because they say, is a prime number a sufficient condition for this to be true? Well, it's not, because we just wrote one that has a remainder of 2 where it's not divisible by 7. So you see, we can X this out. Or that's definitely not a sufficient condition. Now let's take a look at this statement right here. X plus 3 is a multiple of 10. X plus 3 is a multiple of 10. Now that's where this result right here comes in quite handy. If you add 3 to both sides right here, you get x plus 3. X plus 3 is equal to 5x plus 5. Okay, but notice, and this is where that arcane practice of factoring actually comes in handy. If we take a 5 out of here, that should be an m there, I'm sorry. Erase. That should be an m. Okay, this would be equal to 5 times m plus 1. Okay, now let me get a little more space here. Now y'all notice right here, a multiple of 5 can be a multiple of 10, but not always. For example, let's take a look at this case where, let's just say we choose m equal to 6. Okay, so m equals to 6, and y'all can see why I chose that. M equals 6 would create a 7, and a 5 times 7 is 35. That's the motivation. So this would lead to x plus 3 okay, is equal to 5 times 6 plus 1 but that's equal to 35, right? Now 35 is definitely not a multiple of 10, right? It's not a multiple of 10 right here. So that means we have to X out this. All right. And again, folks, I chose m equals 6 because it would induce a multiple that's not a multiple of 10. Okay. So that proves that this condition 2 is also not sufficient. So I think the way they answer the questions on these kind of problems, is you would go neither condition, neither condition 1 and 2 is sufficient. Neither of the conditions is sufficient. I'm not sure, that may be E, the way they categorize these things when you're actually taking the exam. neither is sufficient. I can manage to spell that word. I-E-N-T. And y'all, a way to write this in more mathematically terminology maybe is that 10, right here, 10 does not divide, that's what this means, 35. Okay, another way of saying that is 35 is not a multiple of 10. Okay, but again, the final answer I think is that neither of these two conditions, will make the original condition true. Okay, I hope that helped.